Hello, and welcome to VeEX Broadband Basics. My name is Mike Collins, and I'm a product manager at VeEX. This series of short videos is designed to provide you an overview of the fundamental features of our CATV products. Every video will highlight features of our broadband field meters. So let's get started. This video explains the concept of forward sweep and how VeEX performs sweeping the forward plant when there are OFDM channels present. It's challenging to sweep the forward plant when there are OFDM channels present because these channels have a very large bandwidth. And inserting traditional sweep tones into an OFDM channel is not feasible because this would cause harm to the channel. Since OFDM channels are now normal and are present in almost all CATV plant, a common question we hear is, how do I sweep an OFDM? It is not advised to inject sweep tones within the bandwidth of an OFDM, as this would cause unwanted code words, which is not a good thing. So what can be done? Other manufacturers approach this differently, and here's our approach. All OFDM carriers have pilots or continuous pilots. We sweep off of these pilots and then set sweep tones throughout the rest of the spectrum. The OFDM channel is a broad channel that can accommodate a significant amount of spectrum bandwidth. However, this poses a challenge for traditional sweep, as the large bandwidth of the channel has to be discarded. Due to this, the technicians are unable to view the system's response of the spectrum space within the OFDM channel's bandwidth. So before I get into explaining how we provide a solution for OFDM sweeping, let's do a quick overview of a traditional sweep system. This diagram shows the Kalen 3010H, or the sweep box, inserted in the head end and combined with the forward output signals of the head end. This combined signal, RF and sweep, are connected to the forward path laser, where it is converted into light and then transmitted to the node via fiber optic cable. The node converts the light back to RF signals and then distributes the signals throughout the coaxial RF plant. This distribution network of amplifiers, line extenders, is what the technician will use the sweep signals to balance and sweep the plant to keep the RF signals aligned and configured properly. Okay, with this diagram, I have illustrated some SE-QAMs in an OFDM channel. The SE-QAMs are 6 megahertz wide or 8 megahertz depending on the annex system you're working. What we do is, with our sweep system, we will inject sweep tones in between each of those QAMs. With the OFDM channel, being that it's a very large bandwidth channel, we cannot inject any sweep tones because we would cause errors. So with traditional sweep in an old method, or our past method, when we would go and make our measurements for the sweep tones, we would then trace our measurements and end up with a straight line pretty much going straight through the OFDM, which means no measurements were done in that bandwidth. So as you can see in the sweep trace, it comes out looking like this when you look at a sweep trace done with bypassing or ignoring the bandwidth of the OFDM. VeEX method is we now use the continuous pilots that are contained within the OFDM. As you can see in the diagram of the OFDM here, these little spikes that you see across the top of that OFDM, those are the continuous pilots. We use those spikes and we'll actually go and stop and measure the power of each of those continuous pilots, and then plot that along with our sweep tones that were generated by this transmitter. So by doing that, you'll see that our sweep tones are now being measured, and then we go up and measure the power of those OFDM continuous pilots, and then back down to where our sweep tones are on the other side. By doing that, the trace display that you see shows the sweep response going across to all our sweep tones that we're generating, but once we get to the OFDM section, we'll go and do a dwell on those continuous pilots. We'll dwell for a very short moment of time and capture the power of those continuous pilots across the top of the OFDM. and plot that with our sweep trace. By doing this, the sweep trace is now steady, and those continuous pilots are a solid. They're like CWs. They're continuously generated. They're not like the QAMs within that OFDM that are constantly jumping. It's a steady carrier that we can measure. And by doing that, when you reference this or you normalize off of that, those carriers stay constant, and you can now sweep off and use that plot through the OFDM with your sweep trace. So it's kind of like traditional sweep, where we generate the sweep tones, and sweepless sweep, where we measure across the top of the OFDM and combine the two together to give you a sweep trace of your whole plant, including in between all your QAMs, beyond your last channel and before your first channel, and across the OFDM. So the VeEX Kalen sweep system is a full system sweep of your RF plant. So it's good to know that with our method, you are not bypassing or ignoring the power bandwidth of that OFDM. You are actually utilizing the OFDM's power and using it for your sweep trace. This concludes the short video on forward sweep with OFDM. Thank you, and stay tuned for more VeEX broadband basic videos.